Hello everyone, welcome to my channel. So this is the third part of the series, and in this series we will be doing each and every line of NCERT, and this chapter is biomolecules. And let us begin with fructose. Fructose is an important ketohexose. It is obtained along with glucose by the hydrolysis of disaccharide sucrose. It is a natural monosaccharide found in fruits, honey and vegetables. In its pure form, it is used as a sweetener. It is also an important ketohexose. Fructose is an important ketohexose. It is obtained along with the glucose by the hydrolysis of a disaccharide, that is sucrose. When sucrose is hydrolyzed, you will get two things. One is fructose and another is glucose. So it is a natural monosaccharide found in fruits, honey and vegetables. In its pure form, it is used as a sweetener. It is also an important ketohexose. Let's talk about structure of fructose. Fructose also has the molecular formula C6H12O6, and on the basis of its reaction it was found to contain a ketonic functional group at carbon number 2. Fructose has the molecular formula C6H12O6, same as glucose, and on the basis of its reaction it was found to contain a ketonic functional group at carbon number 2. Carbon number 2, there is a ketonic functional group, and 6 carbon in straight chain as in case of glucose. As in case of glucose, it is having 6 carbons. Similarly, here also 6 carbons are there, but the functional group is ketonic functional group. It is present at the second carbon. Glucose was having aldehydic functional group at the first carbon, that is it was aldose. This is keto sugar, and the 6 carbons are in a straight chain as in the case of glucose. It belongs to D series, capital D series, and is a levorotatory compound. Glucose was also capital D, but it was dextrorotatory, but here fructose is a levorotatory compound. It is appropriately written as capital D in the brackets minus, and this is levorotatory fructose. Its open chain structure is as shown. It also exists in 2 cyclic forms, which are obtained capital D minus fructose by the addition of OH at C5 to the C double bond O group, by the addition of OH from C5 carbon, okay, at C5 carbon to the C double bond OH double bond O group. It also exists in 2 cyclic forms, which are obtained D capital D minus fructose by the addition of OH at C5 to the C double bond O group. The ring thus formed is a 5-membered ring and is named as furanose. The ring thus formed is a 5-membered ring and is named as fructose, with analogy to the compound furan. So the ring thus formed is a 5-membered ring. The ring formed is a 5-membered ring and is named as furanose, with analogy to the compound furan. And glucose was named pyranose with the analogy pyran, which was 5 carbon atoms in the ring and 1 oxygen in the ring, and it was cyclic compound with 5 carbon atoms and 1 oxygen in the ring. 1 oxygen atom and 5 carbon atoms. Similarly, the ring thus formed in ketone. The ring thus formed is a 5-membered ring and is named as furanose, where glucose was named pyranose, because furanose is with analogy to the compound furan. Furan is a 5-member cyclic compound with 1 oxygen and 4 carbon atoms. So here 4 carbon atoms and 1 oxygen. Pyran was 5 carbon atoms and 1 oxygen, but furan is 4 carbon atoms and 1 oxygen atom. So this is furan and alpha capital D minus fructofuranose. COH, H, and from 5th carbon the OH group get attached to the second carbon. Which carbon? Second carbon. And the ketonic functional group is found at second carbon, and C5 get added to the C double bond O group, which is at second carbon. So one is alpha D, where the OH group is at the right side. One is beta D, where OH group is at the left side. The cyclic structure of two anomers of fructose are represented by Haworth structures. In Haworth structures, if you want to see, the outside groups are present. The You can say that the right hand side groups, they are present at the outside. CH2OH, OH, H, H, CH2OH, OH, H, OH, HCH2OH. One is alpha D furanose, another is beta D furanose. Beta D is more stable, alpha D is less stable comparatively. So these structures are very important once go through it. The next topic, that is disaccharide, will continue in the next lecture, and till then please subscribe to my channel, and please hit the like button, and give your feedback about this video in the comment section. I will be waiting for your comments. Thank you so much.